So, hello everyone, and welcome to our second day of webinar Navigating SolidWorks Portfolio, special webinar for our English-speaking African countries. Sorry, and today we have several topics to go on. It will be about simulation with our expert Rick Stanet. You can see him, yeah. And then we will talk about DraftSight. Yesterday I had some questions about DraftSight with Anil Campbell and Maxime Milke. And we will start with a topic about our user groups. Maybe some of you don't know that we have SolidWorks user groups, and we have them in your countries too. So we will start with Derek. And Derek, whenever you're ready, start to share the screen and tell us how it works with user groups.
So good morning, everyone. I'm here to take you through the swagging. If you can just give me a minute to share my screen. Sorry, just a second.
So we can see your screen correctly.
Yeah, so the SolidWorks User Group Network so is meant to be run for SolidWorks users by its users on a volunteer basis. The mission of swagging or SolidWorks User Group Network is to empower people that use SolidWorks products to collaborate with each other, learn from, and teach others. So this happens when the user groups do organize meetings and meetups. Personally, for us, organize on a monthly basis. So what value does this bring to you as a SolidWorks user? The users get the opportunity to improve on their skills with SolidWorks products for free. This enables the user to provide value to the organization which they work for and also achieve their personal design goals. Also, as a user, you get a chance to connect and network with others in the user group community. You'll see that shortly when I share the user group map, the swagging map, and also you get a chance to connect with the SolidWorks brand. So what value does the swagging bring to SolidWorks? So it enables SolidWorks to pass in new information to user group leaders and champions that they pass on to SolidWorks users across the world. It also enables SolidWorks to gain feedback about its product so that they can provide a better user experience. So what's unique about swagging? If you look at the competitor CAD products in the market, there is none which has an arrangement like swagging. So this is a class apart. And two, when you join these user groups, the passion and enthusiasm to learn SolidWorks is amazing among the users. So how do you join swagging? So you visit the page. So how do you join a user group in your area, or how do you find a user group in your locality that you can join? You visit the page www.solidworks.com/swagging map. And if I to show you, so when you visit that page, you'll see, so every red dot that you see there means there is a user group. So you can see the number of user groups that we have across the world. So let's say I'm in Uganda. So I come, I focus more, then it will show me, so the red mark represents a user group in your area. So for me, I'm in Uganda, so I click on that red point. So on the left side, it shows me the name of the group, Uganda SolidWorks User Group, and then a URL to connect me to the link where I can join the group. So I click on it. It's loading. There. So there I can see the group. You can see the members. I can see the location. Then I can actually join the group. Then I also have the opportunity to see the upcoming events. Like for Uganda SolidWorks User Group, you see they have an upcoming event on Friday. So I have the opportunity to see through, and even I can click my attendance and join the group from there. So, so after you have done all this, of what benefit does it do to you? One, so joining and supporting a user group in your region keeps you connected with other SolidWorks users. Two, you also get more opportunity for free training and personal networking. Like if you were to look at that event that I just showed you from Uganda SWAG, we are going to host a presenter from Mexico. So Ugandan users are going to have a chance to connect with a SolidWorks user from Mexico who's going to share his knowledge of SolidWorks with Ugandan users, and also is going to train us on how to gain a SolidWorks certification, that is CSWA. So, and it's for free. You don't pay anything, just join and enjoy. That's all from me. Thank you.
Thank you, Derek. Yeah, welcome to everyone to our existing user groups. And also, if you have no user group in your city, you're welcome to create it. For example, in Kenya, you see that we have user group in Nairobi, but still there are many big cities in Kenya where you can create your user group. So now we continue with simulation theme, and I'm reminding you to write your question in chats, and we'll answer them at the end of webinar. So you can ask about SolidWorks CAD, about DraftSight, about simulation, whatever you want, and at the end we'll discuss it. So with that, here we go with Mr. Eric Chastanet.
Hi everybody. So thank you for joining this session today. So I'm Eric Chastanet. I work for Dassault Systèmes as a simulation consultant. And today we will see together general topics about simulation. But before going too much in the presentation, I will just start with a small video for the introduction. So let's get this video.
How can you design the perfect car before driving a single mile? How do you construct a building that redefines a city before building anything yourself? How can you develop world-changing tech without changing your timeline? The answer is simulation. Physics-based simulation generates insights at every step of product development, allowing your creations to get certified, compliant, and on the market sooner. This means you can build a virtual cruise ship and see how it fares on the open sea. Erect a full-scale virtual twin of a factory and make certain it will be operational in real life. Construct the ideal commercial aircraft and ensure it can withstand the elements. With simulation, no matter what you dream up, it will be enhanced with data, insight, and most of all, revelation. Simulia, reveal the world we live in.
Okay, so this was a very good introduction about the simulation topic. So now we will go a little bit more in detail with the presentation. So I'm going to share my screen. Okay. Can you confirm that you can see my screen?
Yes, we can.
Yes. Okay, perfectly. So we will, let's say, divide this presentation in three parts. First, I will cover the values of simulation. Why do we use simulation? What is simulation? So this is in second here, but don't pay attention to this. We'll start with this. Then we'll see after some domain where we can use the simulation, some with very nice, let's say, examples. So it will be a little bit more concrete. And at the end, we'll see what solution we do have in Dassault system, what type of products we can offer you. Okay. So let's start with and by the way, again, this is an interactive presentation. So during this presentation, I can check the question, for example. And if you would like to see some topics in particular, especially when we will cover the virtual testing areas, I mean, you can just put it in the chat or in the Q&A. So I will have a look and we can focus on it. Okay. So let's start with the value. So what is simulation? So first of all, what we can say is that simulation is for the engineers or the designer, because here it's engineer, but it's also for designer. It's an additional tool to be similar like superpower. Why superpower? First of all, for example, when you want to see temperature on an object, what you can do is you can take a thermometer, but this is not like super precise because it can be very punctual, you know. So having the capability to see the temperature field, it is possible with some special device. You have some special camera to do that, but it's very expensive and it has to be on a real object. And with the simulation, you can get this view of the thermal field, of the temperature field, over whatever type of object you would like to model, you would like to design. So this is kind of a superpower. Again, here there is a picture of an X-ray. For example, if you want to see, again, the temperature inside of a part, this is not possible in the real world. So how you could do that? You could cut your part and try to estimate it. But with the simulation, you can have this view, you know, you can do a cut section in your parts and observe whatever field you would like to see. For example, the density, the temperature, or the stress, or whatever, the displacement. So this is really, I mean, this type of tool, it really gives superpower to the engineer. again, another example is if you would like to see, you're probably right now in a room, if you would like to see the air, where the air is going, what is the velocity of the air? I mean, this is impossible to see because air is invisible, like water. Water is almost invisible. So if you would like to see the field of air, where the air is going, you can use simulation. So this, with a simulation, you will have a complete view or an understanding of where the air is going, for example, in the room. So yeah, we can say that simulation is really a superpower we can give to designer and to engineers. So what are the value of simulation? So we'll see that we have many values, and we have the values will increase, and some also values we will decrease with simulation. So let's start with the value we will increase. First, the innovation. Why? Because when you have simulation projects, you can test many different configuration, and this will boost your innovation on the design. Then the performance, because thanks to the simulation, for example, if I take the example of a car, I want it to be more aerodynamics. So thanks to the simulation, I will be able to do some fluid simulation to try to optimize the aerodynamics. So this, at the end, I will have, for example, a car which are more performant on the fluid side thanks to the simulation. I will also be able to optimize my designs to the needs. For example, if I want to put a beam for whatever usage, thanks to the optimization, I will be able to vary, for example, the thickness, the length of the beam in function of the needs I have, and in function of the load it will cover. I will be able also to explore more design. So this is also part of the innovation, because we'll see that the simulation is connected to the design thanks to some connector, or maybe it's directly integrated on the interface for some specific tools. And thanks to this, we will be able to automate some, let's say, simulation driven by the design. So it will be more efficient. And again, for confidence, when you design something, the question is always, will it resist? Will it be robust enough? You know, thanks to the simulation, so you will be able to anticipate this, and at the end of your design, say, okay, I did the simulation. Now I'm 100% sure that this beam will build strength enough to do his usage. And there are also plenty of values which will decrease. The cost, because you're anticipating all the problems, you are decreasing the cost to develop your project, because you will have less prototype, for example. Again, you will also decrease the time to market, because again, you will have less prototype, for example. You will also reduce the risk of failure of your design, because again, you have already tested it by simulation and you are more confident about your design. And you also decrease the risk, as we say, of the failure and the risk you can get on developing new projects. In Dassault system, we see the simulation in a holistic view. And the goal is really to try to get to as many simulations together, and because one effect, for example, on structural can have also another effect on the fluid side or on the motion side, you know. And we really want to see the simulation as to have this global view, you know, having simulation in all these different domains, which can be the structure, the fluid, the electromagnetism, the motion, the kinematics, for example, the plastic injection, etc. You know, the more you put the simulation in all of these domains, the deeper you go, for example, in your design, in the understanding of your design, and the more complete you will have an overview of the behavior of your conception in the real world. So the market trends today, I mean, the more we go in the future, let's say, or in the time, we observe that the less time we have to develop a new product, because market is becoming more and more competitive, more aggressive. And if you want to, to accelerate this product development, simulation is a very good tool, because as it will reduce the time to market, you will be able to be more competitive. And this is how, is the market trends right now. So this is really the tools, or a bucket of tools which can help you to try to be more competitive. Before, at the beginning, 20 years ago, let's say, or 30 years ago, and again, maybe 10 years ago, simulation was reserved for a certain type of engineer, of specialist people, because the simulation was not really, let's say, user-friendly. It was hard to use, it was complex, it was very expensive, because to run a simulation, it takes a lot of time. You need to have a very advanced laptop, a very powerful laptop to be able to run simulations. And with the tools we develop with Dassault Systèmes, and especially with SolidWorks, but not only SolidWorks, what we want to do, and what we already did, is we democratize this the simulation. So before, the simulation was reserved to specialists, and thanks to this new, let's say, area of tools, we are including the simulation not only for these specialists, but also for regular designer. And today, we have many aspects we could include in this. It's, first of all, the simulation, it's becoming more and more powerful, because we have better solvers, we have better solutions, more robust, more stable solutions. So it's more and more powerful. Also, thanks to the laptops, which are becoming more and more powerful and more accessible. Then we also worked a lot on the interface, on the number of clicks you have to do to set up a simulation. So it's becoming really something which is more and more easy to use. Then we also integrate a lot the simulation with the CAD products. For example, with SolidWorks, today we have some solutions we are directly integrated in the interface of SolidWorks. And you know that SolidWorks, it's an easy tool to do some design. So we really try to keep this, let's say, this mindset of this simulation tool to be very easy to use. And also, we also optimize what we call the post-processing, which is the analyzing part of the results. For example, in a lot of simulation tools now, when the simulation is done, you have plenty of plots of fields which are already done, so you don't have to create them manually. It's automatically done, so you just have to see and watch the results. You don't have to create something you don't really know. So it's really all of these values which help to democratize the simulation. So today, when you're developing a new product, you have plenty of, let's say, facts which will drive your development. First, there is the performance. You'll see that it has to be also a stronger product. You also maybe have to take care of the noise. You have to choose the material, if the material has to be sustainable or not, or if the material is there or not. Sometimes you can have some issues with some materials you cannot get. You have to be more innovative. You have to have lighter products. You have to ensure the quality, have a safe products. The price, you see, it's becoming more and more important in developing a new product. It has to be eco-friendly. You have to reduce the time to the market. You see, you have plenty of facts which will drive your product. So having, again, the simulation, it can take also this, all of this fact can be taken into the account when you're using simulation in your product development. Okay. So we have a brief overview of what is, first of all, the simulation, and what are really the main value which bring the product development to simulation. So now let's see some some area, let's say some area of application where we can use the simulation, okay? So here we can see that we have a lot of, not say domain, but area where we can use the simulation. So this is not the complete overview. There is plenty of more, but this is just a basic overview. So we will not cover all of them because we won't have time to cover all of them. We'll cover just a few of them. So the first one is more about motion, identify force and loads. Then the four first column we can see here, I will put the pointer, it will be easier. The first four columns here, it's more about structural simulation. So simulation on solid parts. Then these two columns here are more on fluid simulations. And the last column we can see here is more on what we call the plastic injection simulation. So let's start with the first type of virtual testing area we can have, which is identify force and columns. Okay. So first of all, when we're doing or building or creating, developing a new design with an assembly with a lot of moving parts, we can, the first question we can have is, okay, because this part is moving, what will be the force needed, for example, to move this part? You know, it's like, for example, when you have a crane, you know, to lift your car, you know, when you build a crane yourself, when you design a crane, what you want to know, you know, the car is approximately 2 tons, and you would like to know for the design of the Vérin, what will be the force needed, you know, to lift up this the car. So this is something you can anticipate and simulate using some solution we do have integrated in SolidWorks. So thanks to this type of simulation, you can really simulate the motion behavior or wall mechanisms. So here you have an example with an animations. So for example, you can see at the middle, you have this rotating part. And thanks to, so you will also reproduce all the behavior of the connector. For example, here you have some hinge, some cylindrical hinge. And thanks to this, you will be able to get the, for example, the amount of torque you need to do this motion. You can take it to the account the gravity. You can also add some friction coefficient in your model to try to really to get a right amount of torque to be able after to choose the right motor, for example, to do this. And you can also anticipate and create some very, let's say, advanced motion simulation to try to see how the complete assembly will work. And this is very interesting, for example, in this type of area where you can have a lot of motion and you really have to do the synchronization of all of these motions. Another one, which is collision and friction. Yeah, for example, here there is a part which is falling and you want to be sure that, I mean, the bucket at the bottom is the right dimension, so it can keep, for example, the piece of wood. Okay, so this type of simulation, we can anticipate, let's say, estimate the force we need to, for example, to animate this with for the cylinder, for example, for the motors. But we could not really, with this type of simulation, we cannot really see the amount of stress inside a part. So for this, you need another type of simulation, which is called structural simulation. And structural simulation is the 4 first columns we can see here. So let's see what what type of areas where we can use structural simulation. First is to try to understand the stress, the amount of stress you have in your parts. So here it's a big pins. Here has some example where we fix the part here, the frame, for example, and after we apply some loads on the frame or on this part. And thanks to this type of simulation, you can see that you can see the deformation of the parts. You can see also the amount of stress you will have in the part. So you really have a deeper, let's say, understanding of what's happening when you apply a load on these solid parts, how it will be deformed, and you will be able to see if the part is robust enough. You will see the area, the location where you will have a peak of stress, and it will be able to drive your design. Maybe you can add some more material on this or change the design and maybe reduce this, what we call hotspots, or maybe in the opposite direction, you say, okay, maybe my part is too rigid, it's over designed. So maybe I can just take off some material, take a thinner part. It will be less expensive in terms of material. So I can reduce also the weight of the part, Another area which is very important is estimating the factor of safety. When you're designing some assemblies in specific area, in specific industry, you have sometimes to respect a factor of safety, because this is the norm. And this is something you can also directly calculate thanks to the simulation, because first you already did a structural stress analysis, and then you can compute directly the factor of safety. So here on this example, for example, we can see that we have a red part on the hinge here, on the middle. And this means that in this location, the factor of safety of 4 is not respected. So maybe I will have to change my design or change the material to be able to respect this factor of safety, So this is very important because in some area, it's required to provide the factor of safety when you design a new part. And thanks to this, you can also document it because we have a report. We can be automatically generated and so you can deliver this report when you have done your conception. Another area where simulation can be also very important is when you have, for example, a lot of bolts and you want to estimate if you have put enough bolts to maintain your, here, for example, for the cap. And also you can see this, let's say, the stress in the bolts to say, okay, maybe this bolt is not rigid enough. Maybe I should take a bolt which is larger, to have more power. So when we talk about connector, it can be bolts, but it can be also welds, so to estimate the radius of your weld, for example. Here it's an example where we put 4 bolts and we will pull on the plates. And thanks to this, we will be able to see the shear stress in the bolt. So we do not directly simulate the bolt. We use some model, and thanks to this model, we will apply, for example, a preload. And thanks to this model, we will see and estimate if we have enough shear stress, for example, in the bolts. Another virtual area, which is very important where you're designing a product, is to estimate the lifetime of your product. Sometimes you can design a product, do a simulation and say, okay, it resists to a certain load, but what about if you apply this load many times, This is called fatigue in structure. And the fatigue behavior, it can be a little bit different than the regular structural behavior. So we also have solution which will be able to anticipate the, let's say, a load which is repeating a lot and a lot of times. So this type of area is very important if you want to estimate the life of your products and to anticipate, for example, some maintenance. You can say, for example, I design a product and I know that with this design, this product, it can resist only, let's say, 10,000 cycles of load, you know. So maybe every 2 years, you will have to do a maintenance to anticipate the failure, you know, of this product. Another area when, for example, you are in competitions in car, for example, in car, but in a lot of sports, you know, is trying to find the best shape, the optimal shape of the design. So here, for example, is for the brake. So it's not the disc brake, but it's what will connect the disc brake to the wheel. And we run some what we call topology optimization. And this type of simulation, it will show you the best shape, you know, you can get for this type of, let's say, structural problem. So thanks to this, it will directly, I mean, drive you to the best shape you can have for a design. So then after you can redesign of the shape which is delivered by the simulation and do a shape you can manufacture easily, for example, with milling, for example, or maybe if with 3D printing, depending on the production you have, you know. So this type of simulation, what we call topology optimization, I will relaunch the video. Oh, I cannot relaunch it. Oh, yes, I have this. So the goal of this type of simulation is really you start from what we call a designer space. Design space is the, let's say, the space you have to put your path, and then you put the problems. So the problem, it will be that for example, the wheel will be maintained in these 3 bolts, and you have all of this, which will be connection to, I don't know, to the car, for example, to the arm of the car. And then you will run the simulation and it will show where you need to have some material to be able to have a part which is robust enough. So this is a smooth part. And after, what you can do is you can just display this part on your regular SolidWorks and design on it, for example. So you can get a part which is more easily manufacturable, for example. So this part, this type of simulation, it really drive you to get a better design with the best shape you can have, because you know where you need to add some material and when you can take off some materials. Other type of, or other goal, let's say, of simulation is try to reduce the material. And for this, so we have, for example, what we just seen previously with a topological optimization, but we do also have what we call parametric optimization. So parametric optimization, what it is? It is when you have done a design. So this is a very simple bracket where we design a big pocket in this bracket, and we will have some design variable, for example, the thickness of each of the branch, and we will vary all these variables, you know, and we test a lot of different design. And thanks to the parametric optimization, we will run automatically different type of, let's say, shapes, and it will show what is the best design automatically. You know, it will do multiple run, and at the end, it will directly find you the best, the optimal design. So it's why it is called parametric optimization, because we are really trying to get the best design. So usually we use a lot this type of technology in in competition, so in sports industry, but also on a regular industry. So because if you have a lighter product, usually it means a product which uses less material, so which is less expensive to manufacture. Another type of domain we can have is when you have motions, when you have vibrations. So here we can also see the behavior of your product when you have vibrations, or to avoid vibrations, or maybe when you have some frequency. Maybe you know what is some frequency or resonance frequency in the products. So having this type of, let's say, simulation, it will, for example, help you to say, okay, maybe you should avoid this the engine to run at this speeds, because if you run at this speed, it will be in the frequency domain of your assembly, and you will have some troubles, because usually you want to avoid the frequency domain. The only thing you like the frequency domain is just when you're doing some music. But if you're not doing some music, it's just if you're redesigning some a project, you know, it's just a bad thing to be in the frequency domain. So you really have to avoid this. How best? Oh, I see also that I have a question, so I will take directly the question. You know, the question is, how best can one interpret the color change on the scales? So this is a very interesting question. So I will go back to, for example, the factor of safety. Factor of safety. So here is the color scale. So, okay, I have a color scale, but how can I interpret this color scales? Usually when, for example, when you are designing with SolidWorks, you know that when it's red, usually it's not good because you have a hotspot. But it really depends on the scales, you know, because this is just a matter of scaling this bar. Usually you have some limits, some numerical limits you do not need to, I mean, you have to avoid. And in mechanics, for example, for the steel materials, you have what we call the elastic limit. The elastic limit is a limit when you deform too much your material, it will not go to its original shape. So this is one limit you can have, for example. So if you adapt, for example, your color to the elastic limit in von Mises, for example, so you will see that you do not have to try to take this to go up to this elastic limit, because when you go up to this elastic limit, you start to what we call plastify your steel, so deform really your material, and so you start to damage your materials. So this is one way of interpreting this color change on the scales. I hope it answered to your question. So please, you can see here there wasn't a question in direct. So if you have a question, if you have a special, I don't know, example you would like to cover, just put in the question. You know, I will go directly in your question or in the domain you would like to see. As I said, it is an interactive presentation. So the more you put question, the better it is. Okay. So let's see another type of domain we can have. Let's say, let's go a little bit in the free, you know, because we talk a lot about structure, because I mean, structure, this is on solid material, so this is, let's say, more easy to understand, but we can do a lot of simulation on fluid. And fluid, this is very important area also, because usually fluid, you just cannot see it most of the time. If it's on air, you cannot see it. It's in just a device, for example, in a van, it's just impossible to see it because you cannot see, I mean, steel is not transparent. So, for example, we have a valve design here. So when you're building a valve, for example, what you would like to see is where is the flow going in this valve, you know, because, for example, sometimes you can have some area where you will have a lot of dust, which will go to your valve, and this dust, it will accumulate in a certain location, and you want to avoid this, you know, to avoid this accumulation. So this is the reason why this is very important to try to estimate where the flow is going when you have a design of a valve, for example, but not only for a valve, you know, we can also, for example, to do some filling example. So here it's what we call free surface analysis. It's when you have, for example, fluid and air or water and air. And the goal here is to see, is my bucket at the right direction or big enough to receive, for example, the jet. You want also, for example, to estimate the turbulence you can have again in your design. You know, for example, here you can see that you have a lot of recirculations, and where is the turbulence of the design? You know, so this is a very cool tool to see to estimate this. So this type of analysis is really give you a better understanding of the behavior of your product. You know. So when we're talking about fluids, so having the possibility to see the fluid, for example, this is very interesting. But also, for example, to estimate the concentration, the diffusion. So this was very important, for example, during the COVID. During the COVID, Dassault Systèmes, they did a lot of simulation in the hospitals to be able to see in a hospital where we should add some fans, you know, some ventilation system to try to reduce the possibility of contaminations. So this was done a lot with tools from Dassault Systèmes. In France, for example, we use, I think, Dassault Systèmes simulation for more than 10 hospitals. Different hospitals, you know, to try to optimize the ventilation systems. So here you can see also in a room, for example, if you're painting a boat, you know, the paint sometimes it's not very good for the guy who is painting. So you would like to locate the ventilation to try to reduce the time of inhalation for the operator. You can do, for example, some atmospheric diffusion, or see the flow and the concentration with drug diffusion, for example, when you're breathing, or how it will condensate. You know, I mean, for example, this is a cooling of a glass. So all of this can be simulated with fluid simulations. Another thing when you're designing a valve or a flow device is to estimate the pressure drop you can have in your device. So this is very important because the more you have a pressure drop, the higher you will need to use a bigger pump, which is a more expensive pump. So being able to reduce the pressure drop, for example, it is very important in a lot of areas because it will allow you to let's say to have less expensive system and to optimize, for example, the flow in certain area. So having the possibility to estimate the pressure drop, this is possible with fluid simulation. And for this, again, we'll see a little bit later in the presentation that we have different tools to handle this. Another thing which is very used in fluid simulation is the possibility to do some thermal simulation. So this is probably the biggest application we have in fluid simulation. Usually when we think fluid simulation, we think that aerodynamics to get, for example, the penetration coefficient of a car, something like that, is the main area, but this is not true. The main area of fluid simulation is thermal simulation. Because with this type of simulation, you can get the temperature in the field, but also you can simulate the temperature field in the solids. And usually when you have solids, the solids, it will be heat or cooled by the fluids. So having the possibility to take into the account, you know, this co-simulation between the fluid and the solid and the behavior of the cooling thanks to the fluid is very, very important. So here, the domain of application is very large because we can see a lot of application in the industry, for example, with the heat exchanger. the question, for example, in this heat exchanger is, should I optimize the flow in function of the pipe, in function of the tube? Do I have enough tubes, to do the coolings? Or also in the high-tech industry, everything which includes electronics, it will generate heat. So when you have this type of device, you can say, okay, I have to put one fan, maybe should I put two fans? Where is the best location to put the fan in my device, So I will optimize the flow, which will cool down many components, many condensator, many heat dissipator in my device. So this is something which is really very used in the electronic industry, the fluid simulation. For example, the difference when you buy, let's say, a cheap laptop and a professional laptop, this is one of the main difference. Dell, for example, which is a laptop, a very famous laptop manufacturer, when you buy a professional workstation at Dell, you can be 100% sure that it was optimized with fluid simulation. So they put the right ventilator to dissipate the heat, and they put the parts, the components at specific location. So it will be, it will be well located, to optimize the thermal behavior. Another area where fluid simulation can be very important is to anticipate the fluid loads. So when, for example, you have a lot of wind, for example, on this panel, which is a publicity panel, so the panel, it will bend. So what you can do is you can run a fluid simulation. So you will get what we call the pressure on the panel. And then when you get this pressure on the panel, you can transfer this result, the pressure, to a structural simulation. And thanks to this, you will be able to run a structural simulation on this panel to see the deformation you can have on this panel. So this is what we call FSI, fluid structure interaction, or we also call this co-simulations. And this is something which is also a lot used in the industry. The possibility to transfer one type of simulation, one result of the simulation, as an input of another simulation. What you can see, the example on the right, it is what we call high coupling simulation. And what we have here is the flow, which is going from left to right, and which is doing a vibration on this part. And this part, usually, it's a simplification of the Tacoma Bridge. The Tacoma Bridge, it's a bridge who failed, I think it was 50 years ago, or a little bit more. And the question is why it failed. It failed because there was a wind, and this wind, it was doing all this turbulence. And you can see that this turbulence has a special frequency. I don't know the frequency, but let's say 10 Hertz. And this frequency, 10 Hertz frequency, was the resonance, the frequency resonance of this bridge. So then the bridge, it started oscillating because it was pushed with this 10 Hertz frequency. And then the bridge, it totally broke. So this can be anticipated again with this type of simulation. Okay, first you do the fluid simulation, so you can see the turbulence here you're creating, and then you can put this turbulence and do a frequency analysis behind it to make sure that this frequency is not in resonance with the design of your domain. Okay. Okay, we covered structural, we cover fluid simulation, kinematics, and let's go to the last column. The last column is more about plastic. So this is also something which is very important. So when you're designing a plastic part, so you can first test it if the plastic is robust enough, but you can also anticipate the plastic injection, because plastic injection is very complex, And what is very important when you're doing plastic, for example, is first of all, can you inject this plastic part? Sometimes, you can have an issue because you will start injecting your plastic part and it will stop because you don't have, the pressure is too high to inject this plastic part, or it cools down too fast. So the plastic during the injection, it's solidified and then it's stop. It's what we call a stop, in the plastic. Then what you can also want to see is how it will evolve, the flow, what we call the flow front. So here is an example of a drill, a simplified drill plastic cover. So what we test here is we test two areas of injection. If we inject by this way or by this way, which one is the best way to inject the plastic part? So here it seems very similar, but in fact, the best way for injecting a part is probably not here, but it's probably in the middle, because here, the more you go in your domain, the higher it will be the pressure to be able to inject this. So the more expensive it will be to inject your plastic part. So maybe in reality, the best way to inject this plastic part is having an injection point at the middle. So then it will you will decrease the pressure of injection. So here you can see maybe here's the best location to inject. Or here is, and what about having multiple injection points? Maybe this is again something which is better. So you will again reduce the pressure you need for this injection. So here it's another example also. So here in this top part, the difference is we just thicken here the outside of the part. And just by having a thicker part here, you will have a flow front which will be totally different. Here you will see that it will close on the left part, it will close, and then at the end, you will see you will have like a big bubble. And this is something you really want to avoid when you're doing plastic, because if you have something like that, it means that you will have some air which will be trapped here. And so you will want to avoid this, because you can have some burns mark in your plastic materials, or directly have a part where you really have a bubble of air, which is there in your plastic material. So it would not be robust enough, So this is very important, to see how your design change can, let's say, change the behavior of the injection, So also, this is what we can see here is some flow fronts. And here we can see that the flow front is very, let's say, linear. So this is very, very good for the injection. In this example, this one here is where we can see this is not optimized at all. Here we can see that we have a air trap. This is a bubble which is trapped here, so the design is not good. So here's another example where we have air trapped in this design. So usually it's at an extremity, this is not really a problem, but when it's in the middle of the material like that, this is not good at all. And here it's also some the flow front we can estimate, and thanks to this, we can see the well lines. And usually when you're manufacturing a plastic part, you want to reduce the well lines, because it's where the part, it will be weaker, or if you have some well line, you have some rules. Because in very complex products, you will always have well lines, but you have some rules, so you make sure that the part will not be too much weaker at this area of location. And here it's another thing you can see when you're doing plastic injection is because when the plastic, it will retract, when it cools. So you will have some mark on the plastics. And this mark, it's the thicker is your part, or where you have more material is where it will reduce more, because you have more material, so you have more material to reduce. So it's where you have the bigger marks on your plastic. We call that, how we call that? I don't remember the term. And this is something you really want to anticipate. For example, if you're buying some Apple device, you know, Apple or some, let's say, high-tech and high quality device, you want to avoid this type of mark, you know. So you really have to pay attention to where you will put some reddish fit higher, for example, in your parts. So try to avoid this type of marks. Then also, what is very important when you're doing some plastic injection is try to optimize the injection process. So for example, what you can do is, okay, maybe I want to inject not only one part, but different parts, you know, and you want to optimize the channel. And for example, you want to inject different parts, so they are not the same parts. So when you're doing this, for example, in this example, what you have to do is you have to try to vary the dimension of the channel, so it's injected at the same time, you know. The cavity are fully filled at the same time, because you don't want to have some cavity which are not filled when the other one is already filled, you know. So you want to balance the filling of the cavity. This is very important when you're doing some plastic injection. Another thing is also to optimize the injection, the cycle of injection, because when you're doing injection, in reality, you have many cycles. You have the filling process. After filling, you have what we call the packing process, is when you put a lot of pressure after filling to make sure that everything is fully packed. And after, you have the cooling process, which is very important. And the more you can reduce each of these steps, the more you will be productive in the production part of this process, you know. So being able to anticipate this and to reduce these cycles is very important. So it's why here the plastic simulation can be very important. And last area we'll cover, and after we'll go to the products, is also to anticipate the deformation you can have on the plastic, because when your plastic will cool, you know, you will see that it will warp, because this is natural, you know, this is due to thermal expansion. So be able to anticipate this is very important, because after, at the end, if you have like a totally banded product, it will not be able to be assembled, you know. So this is very important to anticipate this, okay? So we have seen a lot of area when we can use the simulation. So now let's talk a little bit about the products. So in SolidWorks, we have many simulation products. So first of all, we have the products which are in the SolidWorks interface. So we have SolidWorks Simulation, and for SolidWorks Simulation, which are the products on the left. So these products, so this product are SolidWorks Simulation to do some structural simulation, and also to do a little bit of motion and kinematics. So you can see that here, with this type of product, we can cover a lot of type of simulation. If I go there. So with the first package is SolidWorks Simulation Standard. And with SolidWorks Simulation Standard, you can do what we call static linear simulation. So it's when you apply a load on your device and you just see the stress inside without reaching the elastic domain, the plasticity domain, sorry. And you can go do also some fatigue analysis and some motion analysis. With SolidWorks Simulation, you can do everything which is included in SolidWorks Simulation Standard plus all of this. which is thermal simulation, optimization, frequency analysis, topology optimization also, pressure vessel, some drop test analysis also. And the highest package we have in SolidWorks is SolidWorks Simulation Premium. And with SolidWorks Simulation Premium, you can do a little bit of nonlinearity. Then we have some flow simulation product with SolidWorks Flow Simulation. So this is to anticipate the flow. So for this, we have one regular, let's say, license, which is SolidWorks Flow Simulation. And we also have two additional components, one which is on electronic cooling and one which is on HVAC, which bring you, I would say, some more model for the electronic cooling, for example, or for the HVAC, for the ventilation application. Then we also have SolidWorks Plastics. So for SolidWorks Plastic, we have SolidWorks Plastic Standard, for example, which allow you to do the filling package, the filling process, let's say, so to estimate the well lines, to estimate the what we call the shorts, and the hair traps, the sink mark. Here's the example of a sink mark again we have. Then we do, and we have a big database of material also. When we have a professional package, with this professional package, so it allows you to do the shrinkage of your part. So the shrinkage is when your part will retract. Then you can also do some multi-cavity molds, so to do the balancing of the runner. So you remember the balancing is when you want to balance the filling of your multi-cavity injection. You can do multi-shot. So this is our different material. So this is one plastic and this is one type of rubber, and you can inject. So this is, you can see a lot of this on, for example, the drills, for the tooth, the toothbrush. You can do so, you can put some insert, some fiber analysis, some gas injection. Yeah, and you have a plastic premium where you will have a lot of things about the mold, to put some cooling lines in the molds, and also to be able to see the warpage of your part. So it means that you have a structural analysis behind after the cooling of the part, And then we also have what we call the 3D experience simulations, and this is on a cloud platform, which is the 3D experience. And with this type of product, you will use what we call the abacus. And the abacus, it allows you to do very complex simulations with a lot of deformations. So here, for example, is a rubber. Here is a part, a steel, which is bent with a lot high deformation. Here, it's something which is totally crushed. So this, in terms of simulation, it's very complex simulations. You need very advanced tool to do this type of deformation, because you have some what we call micro buckling, high deformation, plasticity. Here, again, this hydroforming of a tube, of a copper tube. Here, it's extreme bending. Again, here, it's permanent deformations. So for this type of simulation, you need advanced tool we have. And we have also some extreme, again, deformation with explicit damage. So here are a lot of examples. So with this type of simulations, you will be able to do a lot of high dynamics impacts. You will be able to calibrate your materials also to find automatic loss on materials. Okay. So I think we have seen plenty of area of domain of simulation. So here is the end of this presentation. So to remember, what we have seen is the value of simulation. So it gives you superpower to be able to analyze your product deeper. Then we have seen a lot of area, structure simulation, fluid simulation, kinematic simulation, plastic injection simulation. And then we also have seen that we have plenty of products which can cover this type of needs. So if you have some more questions, if you have some needs about simulation, please do not hesitate to contact us, and we will reach you. We'll contact you and try to see what is the best product for your needs. So thank you again, and I've give you the hand to Azamat.
Thank you, Eric. And now we'll continue with the DraftSight presentation. I think many of you are using 2D for drawings, maybe AutoCAD, maybe AutoCAD LT, maybe some other solutions. And now we will discuss with Anil Campbell and Maxime Milke how you can benefit from our solution, DraftSight. So I want to remind you one more time that you can write your questions in the chat, and we will answer them at the end of presentation. So here we go, and I give microphone to Anil and Maxime.
Hello, everyone. So thank you, Azamat, for this introduction, and thank you, Eric, also for this overview of the simulation part at Dassault Systèmes and the amazing abilities it gives you to make your conceptions. Let me share my screen. So I will be talking about DraftSight. So probably some of you guys already know this solution, but for those who do not, I will give a rapid insight, and after that, Anil will take the lead and make actually a live demo. So I hope you can all see my screen. Just a quick introduction about myself. So I am Maxime Milke, and I'm in charge of DraftSight sales for the Geo Euro West. And so rapidly, what is DraftSight? So there it goes. Perfect. So what is DraftSight? So DraftSight is a 2D CAD solution for professionals and made by the Dassault Systèmes. It is a easy to use solution, and it is a native DWG and DXF software. So the purpose of DraftSight at Dassault Systèmes, we wanted to really conceive a product, a solution that would match the needs of our customers who are still using 2D CAD solutions. And this is why with DraftSight, we really tried to give you the perfect tool to continue working pretty much exactly the same as you did with other solutions like AutoCAD. And this is why DraftSight was made on the same language than AutoCAD as well. So there are multiple systems working with DraftSight, including Windows 11, Mac, and Linux. And as of 2017, DraftSight is nowadays the second most popular professional 2D drawing software in the world, with more than 200,000 corporate clients, several millions of users. And these last few years, we have known a rapid growth in our sales of this solution, and this is mainly due to the fact that we now have exceptional capabilities with DraftSight, and also linked to a recent announcement by Autodesk concerning the continuously increase in prices and also the stop of network licenses. So DraftSight is a worldwide used software, since it is deployed in more than 100 countries and is available in 14 languages. So DraftSight is actually working with your DWG files. As I said, it is made on the same language as AutoCAD. So whether you have tons of DWG, DXF files that you work with AutoCAD in 30 years, you will be able to work exactly the same, open and editing your DWGs just like you did with AutoCAD with DraftSight. By the way, on the right side of the screen, you can see the different formats that DraftSight now opens. And it's funny because nowadays with DraftSight 2023, you can even open files coming from AutoCAD that AutoCAD cannot even open anymore since it's too ancient. So it's funny. DraftSight works with DWG files from customers, vendors, and suppliers. It works with DWG files coming from other CAD software, as I said, AutoCAD and maybe other solutions as well. And it basically uses the same technology for DWG files for all Dassault Systèmes CAD solutions. Next thing is that DraftSight is an easy-to-use product. First, we really made DraftSight with the purpose of it being a light software. So it takes only 1 GB compared to 7 GB on your laptop with AutoCAD. And also in terms of the resources DraftSight asks your computer, it's way less than with AutoCAD. So you can also spend on your IT investments in the mid and long term. Then next and very important point is that the learning curve of DraftSight is very, very small. By that, I mean that once again, Dassault Systèmes wanted to propose their clients a solution that would fit exactly their needs of 2D and propose something that was similar, that was already used today by our clients. So just like in AutoCAD, you will have 100% customizable user interface. You will have the ability to work with command line, command alias commands. And even if it's not mandatory, you can also ask your VAR or us directly to give you the manual how to make the switch from AutoCAD to DraftSight, which really goes into details between maybe the small exotic difference you have between both softwares. And of course, I guess you pretty much everyone here already knows how to work in 2D, but in case it is not, you have, of course, a lot of training options available. You can go on Dassault Systèmes webpage, you can go on DraftSight webpage, you can also go on YouTube where you have hundreds of tutorials about the software, how to use it, tips and tricks, etc. And you can, of course, go and see your partner who will be able to assist you anytime concerning DraftSight. DraftSight 2023 works with your processes. So again, it creates native DWG files to share with your production, your customers, your businesses, and managers, and as well as suppliers. Today, one of the strengths of DraftSight is that you will be able to continue working with network licenses, which will work with servers based on technologies like FlexLM or DSLS. And by the way, FlexLM was the technology used previously by Autodesk for the network licenses by AutoCAD that have recently been stopped since a few months now. Concerning APIs, well, it's a very robust product since basically all popular programming languages will be supported, and you can as well create your own custom automation programs. What are the benefits of DraftSight? Well, first, and I believe it's one of the reasons we are so successful with DraftSight, is that we offer a very low annual license cost compared to our competitors. In regular, we see that our customers that made the switch reach almost between 50 and 70% decrease in 2D costs when switching from AutoCAD to DraftSight. So it's an amazing opportunity for you to leverage your investments and also reallocate a part of this budget into a more valuable solution, just like simulation that we saw before. So low annual license costs, the ability to work with network licenses, so ability to have a number of licenses that is in match with your need, because we all know that lots of people using 2D nowadays, pretty much it's for opening a plan, taking a quotation, and just make a few modifications. And this is sometimes it's 10 minutes a day, and sometimes it's not even twice or 3 times a week. So let's continue working with network licenses, and this you can only do it with DraftSight. After that, we have the technical support, which will be made by your partner, and also the possibility to work with GAPI, so work with macro, Lisp, and really create automative tasks in order to get a better workflow. About the DraftSight portfolio, you can see that we have 5 different types of licenses. If we start on the left, we have DraftSight Professional and DraftSight Enterprise. Basically, in terms of functionalities, DraftSight Professional and DraftSight Enterprise is exactly the same. Only difference will be that DraftSight Professional is a standalone version. So one user for one license. It's the same as with AutoCAD today. Whereas on the other side, with Enterprise, you will be able to share the license for 2, 3, 4 people in some cases. So it's also there where you will be able to make a lot of savings on your 2D costs. DraftSight Professional and Enterprise was really meant for individuals or teams requiring a cost-effective alternative to AutoCAD LT. So if you are an AutoCAD LT user, you will feel just perfect with DraftSight Professional or Enterprise because it does exactly the same. You will find basic essential 2D design and drafting capabilities. You will be able to do image vectorization. You can compare drawings, do smart dimensioning, and you can also already work with APIs and AutoLisp, which you cannot with AutoCAD LT. So we go even further on this. In terms of acquiring the solution, you have 2 types, two options. You have the classical option, which is perpetual license, which means that you purchase the solution, you are the owner of it, and then year after year, you can pay for the maintenance in order to have the latest version. Or you can choose flexibility and liberty to always adapt your numbers of licenses by choosing to go with subscription. And of course, for each versions of DraftSight, you will have the full technical support made by your partner. If we go on the middle, we have DraftSight Premium and Enterprise Plus. It's the same story as on the left with Professional and Enterprise. Premium and Enterprise Plus are the same. Only difference is that Premium is standalone, whereas Enterprise Plus is network licenses. So for those 2 versions, it was made for individuals or teams requiring a cost-effective alternative to AutoCAD, the full version of it, because you will find all the capabilities of DraftSight Professional plus capabilities for more advanced users, such as 2D constraints, 3D and DWG design possibilities, and import, export, STL, and SAT formats. So beneath its same network licenses for DraftSight Enterprise Plus, you can go either with perpetual or with term subscription, and you have full technical support. Last part will be the 3D experience DraftSight, which is basically the most advanced DraftSight we have today. And what is it? It is connecting DraftSight to the 3D experience platform, which I guess you already know of. And so you have your DraftSight and you can connect it to the cloud in order to do special data management and also increase highly your collaboration within the teams. And for this 3D experience DraftSight, it is named user licenses and also only with a subscription. So here we are with this overview of the portfolio. Now I think it's the good time for Anil to take the lead and make you guys a live demo in order to see how easy it is to use DraftSight and how likely it is to your possible 2D solution today. Thank you.
Thank you, Maxim, for the presentation. Hello, everyone, and welcome to the live demonstration. My name is Anil, and I will be taking you through this presentation. So the CAD application that you see on my screen is DraftSight Enterprise Plus. Now you may refer this application to AutoCAD. So unlike AutoCAD, you can open drawing files within DraftSight, work upon them, and then save them in release R 2018 to release R12, which is a pretty old version of DWG file. Now, by default, DraftSight Enterprise Plus comes with 3 environments: a drafting and annotation environment, if you still love to work in ribbon type user interface; a classic environment, if you still love to work in toolbars and menus; and a 3D modeling environment, if you would like to conceptualize your ideas. Now, DraftSight is quite flexible. If you would like to make more working space, you can minimize the ribbon bar. And if you would like to change the panel location, you can simply drag it and place it the comfortable location you would like to have. Now, it has quick access toolbar, it has the status bar, command window. So the overall user interface make you feel right at home. Okay. The drawing panel within DraftSight, let me know what all the drawings are open in the application. And if I hover a mouse on particular drawing, it will give me a preview and let me know what the drawing is all about. And then if I would like to find a folder location of that particular file, I can open the containing folder of that particular file. Now, let's say I'm an engineer and working on a heat exchanger closet here, and I would like to create a pipeline here. So to create that, I can make use of line command by just simply typing L into the command prompt. And if I would like to create a rectangular box, I can type in rect for rectangle and then create a rectangular box here. And a few more lines to create the pipeline here. This in general command also comes with extended option. So if I would like to create a 3-corner rectangle, I can easily do that, right? And then again, if you would like to reinvoke the line command, I can go ahead and make use of the mouse gesture. Now, the mouse gesture are easy and handy tool. This will allow me to select the command, invoke the command by just dragging the mouse in that particular direction. So unlike the Microsoft document, you can again match the properties. Let's say I would like to place this particular lines here in the layer of pipe. I can simply select and add them to that layers. You can create the polylines easily and then snap the nearest point of this particular heat exchanger here and drag it and create the pipeline, right? Now, when I select an entity, the grips allows me to play with that entity. So the command shortcuts, e-snap setting, grip settings remains the same, right? Just so there's nothing, as Maxim said, there's nothing much you need to learn about it. Just install the application and start using right away. Now, further moving ahead, let's say I'm having this heat exchanger and I would like to have a 2 wall years. So within DraftSight Enterprise Plus, I can configure the block as per my need. So the DraftSight Enterprise Plus comes with the block authoring environment that allows me to create various configuration of the blocks. So here, let's say I would like to create a 2 configuration of a wall. The one that you see is a gate wall, and the other we can create a ball wall, let's say. So when a ball wall is active, I would like to hide these entities. So here is the 2 configuration of having the ball wall and a gate wall. I can also automate these functionalities, like if I would like to align a particular entities perpendicular to a pipeline, I can add the alignment and then test the block in the test environment and see how it functions. So let's test it. Select the wall and then place it. So if you see, it is behaving the way I want. So once I test this block in test environment, I can then go ahead and close the test environment and save this block as a custom block or a dynamic block of DraftSight. So I can call this block within the drawing and place at the location where I need, right? And I can tag the wall, and then I can have a different configuration of that wall. Simple, right? The other thing I would like to show you is on the modify tool. So the DraftSight also comes with the advanced capabilities. So if you would like to trim a particular entity, you can just simply drag it and trim the entities with the power trim command, and the same command help me to extend the entities by just simply pressing the shift key. The commands remain the same. If I would like to array a particular entity, let's say the chair in this auditorium, and I would like to associate the entities, I can provide the spacing distance between the vertical axis and horizontal axis and create a pattern out of it. Since those entities are associated, I can simply drag it and extend the pattern. Now, DraftSight also comes with the quick modify tool. So within the quick modify tool, I can select the entity. Let's say I would like to copy this particular entity. I can type in C, and then here I place it, and if I would like to rotate it, I'll simply rotate this particular entity. And if I would like to move it, I can select and move it. So a 3 operation in a single command. So you not need to select each individual command separately. Quick modify help me to move, copy, rotate the entity. Now hatching are used to differentiate the areas within the drawing. So the hatch command within DraftSight help me to easily differentiate the area. So here with the contextual menu, I can select the area where you would like to apply the hatches. The contextual menu give me the options what are there within that command, so I can easily access them and use them within the drawing. Okay. Now this drawing is pretty legacy drawing, and it includes the dynamic blocks within the DraftSight. So the AutoCAD dynamic block, I can not only view those configure those dynamic blocks, but I can go ahead and modify them. So when I do that, DraftSight asks me what you would like to do, whether you would like to convert with the intelligence or without intelligence. So I can bring in the intelligence of that dynamic block, modify the dynamic block as per my need, and this block will be then called as the custom block of DraftSight. Since it's a complex drawing, it has a lot of layers in it, and I know one of the member asked the question yesterday, what we can do with the layers. So with the layers, we can add the layers, delete them, show them, freeze them, and many more things. You can also filter out the layers if there are a lot of layers within the drawing. You can filter out by typing in the expression, and you can also group filter them. You can add a group filter, and within that filter, you can add the components that you need within that group filter and filter out the layers, right? You can also define the layer state, include what all the property you need within that layer state, okay, and then work upon it. So layer manager, pretty handy tool while working on the complex drawings within DraftSight. Annotation also play a quite important role. So to add more information to drawing, so you can add different type of note. You can add a single note. You can add multiple notes within a DraftSight. You will get a editor environment where you can add the notes to the drawing. And if you make mistake while adding the notes, the spell check tool help you to identify what are the spelling mistakes you have done and suggest you what changes needed to be done, right? You can add the traditional dimensions, like if you would like to have a linear dimension here, I can add it. And if you would like to add a continuous dimensions, you can easily add the continuous dimensions to a particular component here, like this. Apart from the continuous dimension, you can add a baseline dimension, ordinate dimension, and many more. If you can add the annotation, let's say these are the lifting lux that you would like to let know a draftsman. So I can easily add the note here stating these are the lifting lux, and I can arrange them so that it can be more in a readable fashion. Can add multiple leaders. I can select the component where I can would like to add the leader, and then specify the size of the node and say these are the stiffeners. And then once I add it, I can add the another leader specifying this is also a stiffener that he may refer to. You can do automatic dimensioning to a component. So let's say this is the plate where you would like to add automatic dimension. You can apply the bounding box, select the auto dimension. Within here on the right side, you can select the scheme, how you would like to place the dimension, and on which geometry you would like to include for the automatic dimension. So I can select, let's say this is the geometry I would like to select for auto dimensioning. I can have a preview how this dimension will get placed, and select the dimension that I would like to have for that particular component. Now DraftSight also comes with the dimension palette. The dimension palette helps me to add more information to a drawing. So I can add, like, these are the 4 quantities of hole of dia 18. I can add a tolerance set to that particular dimensions. So this is like kind of having a deviation of 0.0, 0.2 to 0.5. I can go ahead and save this template and can make use of it when when needed. So dimension palette. If you know SolidWorks or are a user of a SolidWorks, you may know how useful the dimension palette can be, right? I can again then select a particular drawing and auto arrange the dimension on the basis of this roller. So I can easily play with the dimension and add more information to a particular drawing. We can add the smart dimension to a particular component. I can just select the smart dimension, allows me to add a dimension based on my mouse movement. So wherever I take the mouse, it will add those dimensions. So we can also insert the Excel file within the DraftSight. So we can always link the OLE objects within the DraftSight. Since as we saw this complex drawing includes a lot of layout in it. So I can easily have a batch print of this particular drawing. I can say print and have a batch print, and the batch print will help me to print the drawing in various paper sizes. And here is an example that I have already have for you. So this is how the print quality you'll get, nice, and with all different type of paper set. So the next very important thing we really engineers work on is on the PDF. So within DraftSight, you can import the PDFs and edit and modify those PDFs. You can select the page that you would like to insert and place the location and then work upon the PDF, right? So the PDF entities, like the PDF line will be identified as an line, and PDF text will be identified as a DraftSight text. So you can do the modification to the PDF imported. Likewise, you can also export the PDFs, right? The next thing is on the references. You can add the references to a drawing. So let me bring in few references to show you how you can make use of the toolbox that we offer with Enterprise and Enterprise Plus as well. So here is like an engineer who is working on the left hand cover, and then there is another engineer who is working on the right hand cover. Can attach those references and then make use of toolbox to add a screw connection assembly. Now this toolbox comes with the standard component library of ANSYS, metric, BSI, DIN, ISO, and JSI. You can copy one of it and make your own company standard and then utilize it. Now for the demo presentation, let me insert a screw connection assembly here. So let me add the type, like what kind of a bolt you would like to place, what size of a bolt you would like to have, and apply the material thickness. Material thickness is nothing but the distance between these two plates, and then you can have the fastener length. You can define the fastener length here. You can define the I can go ahead and select more components here. Right, so screw connection assembly and select the hexaheld bolt with the size and the material thickness, and add in the washers, have the bolted place here. You can add the nuts on the nut side and stuff like that, and place the bolted connection assembly. But then it's okay. So this is how you can make use of the bolted connection assembly. All right, and then I can add the washers and place the bolted connection assembly. Right. So this is how you can add the bolted connection assembly. And if I would like to do modification in the assembly, you can edit it and then change the size, and then can proceed with the work. So if you can imagine what kind of an task it takes to recreate the screw assembly if there are any modification in it. Now DraftSight also comes with the power tool. So if you would like to compare the drawing versions, you can bring in the drawing versions of a particular drawing and then have the differences, seen what all the difference that has been done, what are the additional things have been there, and what are the things that has been removed from the earlier drawing. So you can compare the drawing with the draw compare tool. You can also generate the G codes, okay, for a particular component, like this one. So if you have a sheet metal component and you would like to generate a G code for a CAD operator, you can define the kind of a path, 2D path, select the path that you would like to create a G code generation and G codes for, and save it on, say, desktop, and that's how you can create the G codes here. And the image tracer capabilities help you to convert the raster images into a vector quantities. Like for an example, here I can attach the drawing and attach the image, sorry, and then bring in that image within the DraftSight, place it on the location, and then can have the image tracer run. So image tracer will help me to convert this raster image into a vector quantity. So I can then copy this or extract this and place it somewhere here to show the orientation of this particular assembly here. So I would like to show what is the north direction, south and west direction to a particular production team, so they can understand how the assembly look like. So this is how is the DraftSight. So it has many more capabilities. Since looking at the time constraint, I did this is what the things that I wanted to show you. Yeah, there's one more thing on the 3D part. So you can have a 3D modeling environment, and you can have a kind of a let's say this is the view, and if you would like to have a flat snapshot of this particular drawing or this particular 3D utility, you can take a flat snapshot of this 3D drawing and place it, and then can use it. Right. Well, these were the things from my side. So I hand it over to Maxim. Over to you, Maxim.
Yes, so let me just recap quickly. Thank you, Anil, for this demonstration. I think we all understood how easy DraftSight is to use, and how you can use this solution in order to fit your current 2D CAD needs. So if we come back to the presentation, let's move on to the last slide. So as a recap, let's remind that DraftSight serves more than 200,000 companies worldwide. So people are happy about it. People renew their licenses every year, and the numbers keep growing. In addition to your 2D CAD needs, the DraftSight portfolio will address the flexibility required by businesses and their ecosystems, especially with the ability to continue working with flexible licenses, network licenses. DraftSight will continue to evolve as a product, especially in productivity and automation features. And finally, the savings made will allow the budget for CAD transformation to be increased, because whenever you will change from a solution like AutoCAD to DraftSight, automatically you will be able to save a lot of your budget allocated to the CAD, and thus you will be able to reallocate this budget into more valuable solutions like an additional SolidWorks license, access for simulation or 3D experience, for example. So if the presentation convinced you, and I hope it did, if you want to try it out yourself, well, you can just ask us directly or your partner, so we can send you a free evaluation license for 1 month. That's it for me. If you have questions, do not hesitate. We are here to answer them.
Maxim, I think we have a question on DraftSight. It's from Stephen. It says, hi, can we nest designs in DraftSight? So if it is like a block within a block, a drawing within a drawing, or something like that, yes, we can nest that. Or if it is with respect to the NC sheet metal, where with nesting comes in, that capability. But nesting with the blocks, yes, we can do that.
Thank you, Anil. And also, yes, if you have more questions, you can write them as fast as possible, because we are going to close the presentation soon. I want to thank you again for coming, for joining us for these 2 days, and I hope that we will make it more often, and we will invite you for sure for next times. And yeah, one more question: can the recording for both sessions be accessed, and how? Yes, very soon our colleagues from ADCC will share with you recordings for both sessions. We recorded them, and maybe you are watching the recording right now. So with that, I think Marius wants to say something.
Not really. I just turned on my camera. But maybe just a big thank you for everybody that attended today and attended yesterday as well. There are a lot of people that registered that could not attend, maybe had some issues connecting. The recording link will be shared with everybody, so please have a look at the recording again. And maybe, Azamat, I'm not sure if it's too early to mention about the July event, in-person event.
Yeah. However, it will be recording, and maybe someone is watching us already in July.
Yes, so we are planning a small trip to Kenya in the month of July, so with the intention to do a customer event. So some of the people you see on this call will be traveling with us there and be co-presenters. So if you like what you've seen today and you want to know more, come and visit us, speak to our partner ADCC, who will be the sponsor of this event, and guest speakers and keynote speakers as well. And there's much more to the portfolio than what we just covered, but we didn't want to overwhelm you. We just wanted to pique your curiosity to show you that there's big interoperability between all our solutions that can support you end to end from concept all the way through to manufacturing. So with that being said, thank you to all the presenters today. Thank you to all the attendees. And for those that we'll see in person in July in Kenya, we look forward to meeting you and putting a face to a name. All the best, guys, and take care. Thank you.
Thank you.
Thank you very much.
Bye.
Bye-bye, guys.
Thank you. Bye-bye.
Bye-bye.